So you click on this video because you expect me to grab a bunch of chemicals, lock myself in the lab, 3D print weird stuff and spend weeks only to make my own lab-made banana and try it at the end. And fair enough, you're not wrong. Welcome to Element 44. Let's get started. Let's start by figuring out what a banana actually is. Sounds simple, right? It's a berry. Yeah, it's a berry, not a fruit. We don't care about that. What we care about is why people love bananas and what makes a banana smell like a banana. We're chemists, right? So we care about molecules. Turns out to make something smell banana, you don't need a ton of compounds or some insanely complex synthesis. All those banana gums and candies mostly rely on one compound that gives almost the full banana aroma, isoamyl acetate. It's an ester of acetic acid. And yes, it's used as solvent for paints. So yeah, the same chemical used to thin paint is officially used in artificial banana flavor in candies. Scary? Maybe. Interesting question. Is isoamyl acetate actually present in real bananas? And answer is yes. I found a study where they mashed banana to a pulp and measured the volatiles, and isoamyl acetate made up about 5% of all volatile compounds. That's quite a lot, and it again proves that this compound isn't scary at normal concentration. So my first mission is to synthesize isoamyl acetate. It's pretty simple reaction. Isoamyl acetate is an ester. One half comes from acetic acid, and the other half is an alcohol that on its own smells pretty awful, like smelly socks. The weird part, two compounds that each smell bad in isolation can combine into a molecule that smells like a banana. Let's synthesize it.
Step 1. Isoamyl acetate. Attempt 1.
There are lots of videos on YouTube making isoamyl acetate because it's well-known Fischer esterification, and this reaction has one catch. A big catch. For this reaction I need concentrated sulfuric acid. Mine ran out, so I started thinking what I could replace it with, because I really didn't want to mess with distilling boiling sulfuric acid. Honestly, that's the last thing I want to do. The problem with the Fischer reaction is its sensitivity to water. Sulfuric acid acts as a strong dehydrating agent and a catalyst for this process. But I found a very interesting paper where they used water-absorbing agents as a replacement for concentrated acid, specifically 3A molecular sieves. For those who don't know, these are porous beads of aluminosilicate whose pores are sized so water gets trapped while other molecules pass by. There is also the method with the Dean star trap to remove water isotropically using different solvents. But I didn't have Dean star nor concentrated sulfuric acid at that moment, so I decided to remove water from the reaction using molecular sieves. I wasn't super confident in that method, and I thought the result could be bad. So we need glacial acetic acid, diluted sulfuric acid, isoamyl alcohol, and really well-dried activated molecular sieves. Now I'll quickly mix it all, heat it up, isolate the product, and explain the reaction. If you repeat this, remember, I always leave files on Patreon with the exact numbers and explanations. After extracting, washing, and isolating the product, I set up the distillation, evaporated off dichloromethane, and collected fractions around 142 degrees. The problem was that I didn't have a proper thermometer. I was using the wrong one, and I couldn't accurately measure the temperature of the fractions. And I honestly didn't think I was getting isoamyl acetate, but I still collected 4 small vials. All the while I kept trying to sniff for banana, and I got it. A tiny banana note buried in a cloud of paint thinner. The place smelled like a paint shop. That's when I started digging online and learned that isoamyl acetate smells like banana, only at very low concentrations. Really, very low. I decided to check the smell again. I opened the fridge where I kept the vials, and suddenly there was a pleasant scent. Guess which one? Banana. I think that happened because only a tiny amount escaped past the caps, so the concentration in the fridge air was just right. That convinced me I'd actually made something I wanted, but still, the overall smell was very chemical and I didn't like it. I got disappointed and shelved the synthesis. I put the vials back in the fridge and moved on to other projects. Fast forward a year, I've got the itch again. Time to get that true chemical banana.
Step 2. Isoamyl acetate. Attempt 2.
And I think you already guessed. This time there will be no molecular sieves, there will be sulfuric acid, concentrated. We're repeating the same procedure as before. This time I ran the reaction with a larger excess of acetic acid, 5 equivalents. To drive the equilibrium toward the product, I mix the reagents and reflux the mixture for 3 hours. This time everything definitely went differently. The reaction changed color, and I was really happy to see that. When it finished, I let it cool down, poured everything into a beaker, and prepared some baking soda. So yeah, we're about to do the hardest experiment in chemistry, mixing vinegar with baking soda. In short, I needed to neutralize everything because we used an excess of acid. When the pH was neutral, I poured the mixture into a funnel and washed it several times with water and sodium carbonate. After that, I dried over sodium sulfate and prepared to distill. I set up the distillation apparatus, and this time I put a proper thermocouple in the system, so I could better control the temperature. The first fraction came off at 141 degrees Celsius, which is below the boiling point of the acetate, so I think it's a mixture of isoamyl alcohol and our ester. After the temperature reached 142, I started collecting the second fraction and finally the last third, and here I was a little disappointed. Everything around smelled like paint, but this time it was definitely the acetate. On the one hand, I proved that the molecular sieves method works. On the other, I spent a year thinking I hadn't made it and messing with this acetate to make the same thing that smells like a banana marinated in a jar of paint.
Step 3. How we're gonna test it.
I think the best way to get banana flavor into the shape of a real banana, I searched Amazon and other sites, and every mold was either tiny or didn't look like a banana at all. That's really bad, guys. Please, someone start selling proper banana molds. So I had only one option left. Make it myself. I spent an entire evening banging the mold together and getting it perfect. I wanted the banana to be real size, and I ended up with 2 half molds like this. They're beautiful.
Step 4. 3D printing a banana.
It's been collecting dust on the shell since the dinosaur era, so I gave it a quick clean. Swap in PLA filament. It's listed as food safe, but I'm not sure. Plug the CD card in and started printing. By morning, I had 2 molds and I was ready for the next step.
Step 5. Banana kitchen time.
I spent some time on cooking websites, strange cooking websites, and I found the perfect jelly recipe. Everything we need is on the table, and our secret ingredient is also here. So we add gelatin to a bowl and pour in warm water. We give it half an hour to bloom. Next, we put a saucepan on the stove and melt the sugar in water, bringing it to about 115 degrees Celsius. We add the color and wait until everything cools down. And now comes a very responsible step, because this will decide whether I stay alive after this test. I found an official document from this organization stating that for jellies, the maximum recommended concentration is 100 ppm. And we already know why. They add so little because at lower concentration, isoamyl acetate smells like a banana, so it tastes like a banana. But at high concentration, it starts to smell like a paint thinner. Here's what I came up with. I would take 25 grams of glycerin and add half a gram of isoamyl acetate and mix it well. We have a 2% solution that is easier to dose. Simple. Wait, not so simple. I realized isoamyl acetate isn't soluble in glycerol, so I dumped that and quickly made an ethanol solution from vodka at the same concentration. We mix everything together and pour it into the molds. I cover them with cling film to make it easier to remove and actually safer to eat. We now leave it for a few hours to set.
Step 6. The final taste test.
Just a quick disclaimer, guys. The consumption of uncertified chemicals is dangerous. Do not attempt to replicate or try anything shown in this video. I'm professional, and everything here is performed safely for educational purposes only, using very low concentrations that are safe for human body. So, it's finally time to test this banana. Obviously, the taste of a real banana is a super complex thing that comes from different compounds, but I wonder if isoamyl acetate can give at least some vibe of banana. So this tastes exactly like that artificial banana flavor from bubblegum, and I like it. So yeah, isoamyl acetate confirmed. It does taste like banana, artificial banana, and honestly, it's nice. I like it. Don't forget to subscribe and smash that like button. See you in the next video.